My name is Russ Kennedy. I'm the Chief Product Officer at Nasuni, and I'm going to give you a quick technical overview of the Nasuni platform for file data services. So there are 5 key components to the Nasuni platform, the Nasuni File Data Services platform. And I'll describe these in a little bit of detail, and I'll go into some more detail on the cloud services components, if you will. So first and foremost, the key component to the Nasuni platform is UniFS. This is our global file system designed from day one to run in object storage, to run in public cloud object storage. We also support some of the private object store vendors that are existing in the marketplace for customers that want to keep all of their data on premises. But for the most part, our customers take advantage of AWS, of Azure, and of Google public cloud object storage. UniFS is a continuous versioning file system. You can save multiple versions of your file system, and you as the user get to designate how frequent those versions are created and how long I want to keep those versions. It is, we call the gold master copy of your data. Lives in the cloud, lives as objects in the object storage system, and is immutable, meaning every version cannot be changed. If you change the file system, we save a new version, and you keep as many previous versions as you want to for recovery points. That's UniFS. That's the core to the file system. Users and applications access their data through the second element, which is a virtual edge device. Typically, it runs as an appliance on a virtual machine, either in a data center, in an office, in a manufacturing facility, wherever users and applications exist and are accessing data, that's where a virtual edge appliance lives. It has a small amount of cache storage to store active data locally, but it's a copy of the data. The permanent gold master copy lives in UniFS in the cloud. A cache copy of the data lives at the edge. And as changes are made or new files are written, that data is then saved to the cloud as a new version, and previous versions exist for recovery points. So that's the virtual edge component of the platform. The third component is a management console. This is also a virtual machine instance that lives in the customer's environment, either on-premise in a hypervisor or in the cloud, and it is your window into the Nasuni environment. It has access to information, statistics, et cetera, about the operation of the edge appliances and the volumes that you've created in your environment. It also gives you the ability to set up new edge appliances, set up new volumes, set up snapshot schedules, recover data if you need to. All of that is through the management console. It has a web-based UI and a REST-based API to be able to manipulate and manage your infrastructure. But the management console sits out of band. It doesn't touch customer data. It sits out of band and manages the entire environment. So those are the 3 key components that sort of live with the customer, if you will. Now I'm going to go into more detail on the 2 cloud services components. One is the Orchestration Center, which again, as I mentioned before, manages all of the data sharing and synchronization across multiple locations. It also performs a function we call global file lock, which prevents users that are manipulating the same file in 2 different locations from stepping on each other or from conflicting with each other, if you will. It performs that function in a cloud service. The other component is the analytics connector, and the analytics connector allows customers to go into their UniFS data and export that data for analytic purposes in the cloud. So they can reach in, grab a piece of information or the entire file system if they want to, export that data so that it can be input to an analytic service, an AI service, a machine learning service, search indexes, compliance regulations, et cetera. They have access to that data outside of the file system. So it doesn't change the performance of the file system. It doesn't change the file system at all, but they can access the data so they can input it to an analytic process.
So I've got a question about the global file lock.
Yes.
Because that can cause challenges depending on how you're actually using the data.
Sure.
Can I turn it off?
You can. You actually can turn it on for whichever data you want to be under global file lock. And it's done at a share level or a directory level or at an entire volume level if you want to, but you don't have to have it on. You can be very granular and say the data in this folder, I want to have lock on, global lock on, and everything else, I don't want to have lock on.
Okay, so and which is the default?
Default is off. You have to actively turn it on as a customer, as a user.
Yeah, okay, cool.
All right, so Orchestration Center, again, this is a cloud service that we built and we manage on behalf of our customers to deliver file synchronization across multiple locations. So all of our 660 customers leverage the Orchestration Center to do that synchronization across multiple locations. And it performs the global file lock feature, the global file lock functionality. And again, in order to have a global file system, lock management and lock processing has to be at the global level. That's why we built the cloud service, to be able to manage that. It exists in multiple AWS regions around the world, and it exists in a high availability environment. So 2 regions are paired together so that if there is a problem in one AWS region, all of the activity and all the processing fails over to the other AWS region that is paired to. It also has elasticity built in. So as more and more requests hit the Nasuni Orchestration Center, it adds resources as it needs. If those requests go away, it shrinks the consumption of those resources. So it's very elastic in that sense and very highly available in that sense. So users can get the level of performance and activity that they need through the Nasuni Orchestration Center. Just some statistics. I mentioned some of these before, but in 2021, we processed 50 billion API requests through the 3 regions that we're managing Nasuni Orchestration Center services in. That's North America, EMEA, and Asia Pacific. That's up 22% from 2020. And it's actually in the first quarter of this year grown even further than that. So last year we averaged about 1,500 lock requests per second. We're now over 2,200 lock requests per second across all 3 regions that the Nasuni Orchestration Center operates in. It also performs other functions like licensing and understanding and managing upgrades to the software, et cetera. But primarily it manages lock requests, and that's what our customers use it for. Because it's a cloud service, we're able to make changes to the Nasuni Orchestration Center on a fairly frequent basis. We actually did 100 releases to the Nasuni Orchestration Center service last year, again, without interruption to our customers.
Again, a question on this.
Sure.
Is this cloud application running as part of your cloud, or is it running as part of the customer's cloud?
This one runs as part of our cloud. We manage this for customers. They don't see it, they don't pay for it. They get it as part of their Nasuni license. It's a service that we operate on behalf of them to do sharing, synchronization, and locking.
And do you have like the clear delineation of what runs in your cloud and what runs in and what's in the customer's portion of the cloud?
Running in the customer's environment, whether it's on premises or in the cloud, is the container that contains the UniFS file data. So the object storage container, either a bucket or a container, that runs in the customer's tenant. They manage that. That's their storage. Okay. They manage it. The appliances run wherever the customers want them to run, the edge appliances. They can be on-prem or in the cloud, but that's within their tenant. The third piece, the management console, that's also within their tenant, either on-prem or in the cloud. So those 3 pieces are all within the customer's environment.
Okay.
This orchestration center runs in AWS, but it's Nasuni controlled. Nasuni pays for it, Nasuni manages it, Nasuni runs it. We make changes to it. That's our responsibility. The 5th component, which is the analytics connector, is also a cloud service, but it runs in the customer's tenant. So it runs in their tenant. They pay for the resources to extract the data out of Nasuni and make it available for analytic purposes. So that also, even though it's a cloud service, it's part of the customer environment. So 4 of the 5 components are customer managed, customer controlled, customer resources, if you will. The 5th component, orchestration center, Nasuni runs and Nasuni pays for it.
Okay, thank you for the clarification. That was exactly what I was looking for.
Perfect. All right, just a little bit about uptime and availability in the Nasuni Orchestration Center. Again, 3 regions across the world that we manage. North America is between Virginia and Oregon, those regions in AWS, and they're highly available, highly active pairs, active pairs, if you will. So if there's a problem in, like say Oregon, which had a problem last year, all of the processing activity fails over to Virginia. So our customers didn't see any outage or any issue associated with the Oregon outage. Ireland and Frankfurt operate in EMEA. Sydney and Tokyo operate for our Asia Pacific customers. And again, the availability, you can see the numbers there in terms of availability of the service for our customers. The analytics connector, again, the fifth piece of the platform that we make available for our customers, is a cloud service that runs in the customer's environment. It gives them the ability to go in and pick some portions or all of their file system to export that data for use in analytic purposes. So it goes in and takes the data out of UniFS format, reconstitutes that data in native object format so that it can be input to an analytic process, build search indexes, search for compliance irregularities, do AI, do ML, those kinds of processes. And again, it's happening behind the scenes from a file system perspective. So it doesn't impact the performance of the file system. Users continue to interact with the file system as they do. This just gives our customers the ability to go in and look at their data, leverage that data, make decisions about the contents of that data so that they can manage their environment much more closely.
We've heard a couple times about the changes being immutable.
Yes.
Can we talk a little bit about the tech that makes it immutable? Not secret sauce, but
sure,
right?
Sure.
What makes it immutable from that perspective?
So inherently, object storage is immutable. The design and architecture of object storage, when you write an object, you write an object. If you change that object, you typically write a new version of that object, and you may want to keep previous versions of that object if you want to recover to those previous versions. But inherently, object storage is immutable. And then we, on top of that, layer intelligence to say, this is part of a snapshot. It cannot be changed anymore. If you make a change, you create a new version, and any of those changes get saved as part of the new version. And the pointers back to previous versions are maintained in the current version. So you're able to go back and retrieve and recover if you need to. But we're building on the inherent immutability of object storage, just leveraging the capability that it has inherently.
Okay, thank you.
If it is changed like that, what if you want to recover something from a year ago? Is there a time cost involved?
There is no time cost. Again, all of that data exists in your container in the object store, all the previous versions and the pointers to those previous versions. So if you have a year's worth of data, it all still lives in that container. Very easy to point back to a year ago and say, this is the data I want, restore it back to now.
Okay.
Hi, hello. So
yes.
I have a question about the edge appliance.
Yes.
Is it a hardware that is like installed in like an AWS region? I'm still a bit confused about that actually.
So the edge appliance is a small server. It runs Nasuni software as an application. It's a Linux-based appliance, so it's a Linux OS running typically on a hypervisor. So typically under ESX or Hyper-V or Nutanix or KVM or some hypervisor, okay, running the Nasuni software. The appliance has some local storage associated with it, some amount of capacity. Typically, it's a few terabytes, maybe up to 20 or 30 terabytes locally to cache active data. So the active data lives, a copy of the active data lives in the cache locally so that the performance for the user is as if they're talking to a local file server, okay? Yeah. But the gold master copy of the data lives in UniFS in the cloud. And our software keeps the data in sync. So if there's changes here, those changes get pushed to the cloud, they get versioned as a new version, and then that version is available for any other appliance that is sharing that volume so they can get access to that data.
Is it a regional service on AWS or like a global one?
So the appliances themselves can live anywhere. They can run in EC2 in AWS. They can run in Azure Compute in Azure if you want to have your appliances in Azure. So they can live in the cloud. The appliance can actually live in the cloud. It just takes advantage of a virtual machine running in that cloud. Yes.